Hi everyone. In this pulley problem, we have two blocks, M1 and M2, connected by an inextensible string over a pulley. Now, you should note that the pulley itself is massless. When we get to rotation, pulleys will become massive, and that will play an important role in the system. Now, this is a typical example of a connected system, and how we analyze connected system is a little different. So our task in this problem will be to calculate 1, the acceleration of the system, and 2, the tension in the string. Now, here are a couple of things you should note. 1, M1 is connected to M2 by a taut string. The fact that the string is taut means that the tension in the string is the same. Now, let me repeat. The tension in the string is the same because we have made a fundamental assumption that the pulley itself is frictionless and massless. If the pulley is not frictionless or massless, then the tension in this section of the string will be different from the tension in this section of the string. But in this first example, we will assume that the pulley is massless, making the tension different. The same, sorry. Now, the very first step that you need to do in any problem given to you that involves forces is for you to draw the free body diagram. So we will draw the free body diagram for M2. This is M2G. That is T, M1G, Fn. Well, let's assume that there's friction. Remember that we're going to assume that the surface is frictionless, in which case, when it comes to connected bodies, they accelerate with the same acceleration. So we will apply Newton's second law for block 1 separately and for block 2 separately. Now I'm going to take the direction of motion to be positive. Let me say that again. I will take the direction of motion to be positive, which means that M1 is accelerating in this direction with an acceleration A, and M2 is accelerating in this direction with an acceleration A. So with respect to M1, the sum of forces will be equal to T, and this is just M1A. Let's call this equation 1. With respect to M2, the sum of forces, the direction of motion is positive. So downward in this case is positive. So we have M2G minus T will be equal to M2A. Let's call this equation 2. From equation 1, T is equal to M1A. So if we substitute that in equation 2, we will have M2G minus M1A equal to M2A. We're going to take this to the other side of the equation. So this will be M2G equal to M1A plus M2A, which is M1 plus M2 multiplied by A. This means that the acceleration A is just M2 divided by M1 plus M2 all multiplied by G. This gives us the acceleration of the system. Therefore, the tension in the string T, which is M1A, this will be equal to M1 M2 divided by M1 plus M2 multiplied by G. This gives us the tension in the string. I hope this helps. This is a very important question. Watch this video over and over again and make sure you get this. If you have any questions, please don't forget to ask questions on the comment section below. I'll be able to help you more. Subscribe so that more videos, when uploaded, you will be notified immediately. Thank you so much and remain blessed.